generated, then the randomness is gone, right? So, okay, so anyway, so we're going to now just explore all this by doing actually a lab, right? Interactive, as I want this class to be. So you see there's a link on this page. We will use this notebook for an analysis. If you can click on this link, and actually I will stop share, and I don't know who. Okay, excellent. Okay, so I should just go back to which link you clicked on. Yeah, you clicked on this link. Everybody click on this link. It should open up this new page. Okay. Okay, so this, I just want to explain to you what is it. Since we're talking about data science, one of the tools that was used for data science is what I'm going to show you now. And I've created a cloud hosted instance, so you don't have to install anything locally. Okay. So now you need to sign in. So if you can click on that sign in button, and I'm hoping that all of you are on Windows machines and you have a Hotmail sign in already. If you're logged into your Windows machines, it should automatically work. Otherwise, you have to click on your Hotmail account and just log in. Yeah, that's it. Yeah, just use your whatever your Microsoft login is. Just use your Microsoft login and you should be good to go. Say yes, that's fine. It's, by the way, this infrastructure is hosted by Microsoft. It's a free service right now. So it allows us to run Python code on the server, right? So you will get your own installation of Python, hopefully in a minute. Yeah, and then okay, so does everybody have this now? Anyone not able to do this? I'll wait for a second. But the important point is, Ashish, you see this thing that says clone there? To the left, yeah. So before you click, so everyone can see, there's going to be this button called clone. If he clicks clone, he will get a copy of this whole infrastructure. So if you click on clone, you're going to get a clone. If you want to give it some other name, you can, otherwise just say clone. I don't think you need to read
it. It's okay for public library.
Yeah, that's fine. It just means that whatever code you write will be visible, but it's okay. You can just delete all this after we're done. Okay, so now I think you got a clone. Now you can hit this run button. There's a run button. Yeah, hit the run button. So now you should have a running working instance of Python, but the Python is actually running in the cloud. Just like when you did the labs, the other labs, this Python is running in the cloud. Okay. And now you click on the introduction to data science. Yeah, exactly. Click on this. And Ashish, I'll make you drive a little bit. So everyone, rather than me typing, we can have you do some things and we can observe this together. Okay. So what are we doing here? We are basically working with a cloud hosted instance of Python using an editor, which is called a Jupyter Notebook. And I'll show you a little bit of the power of this editor. Okay. So as soon as you get this editor, you can basically start running code. Okay. So first thing is you need some place to actually write and run code. So you can just, I use shortcuts a lot. So if you hit escape and hit escape A, yeah, you get a blank cell, empty cell. You see A for above. If you hit escape B, you'll get a cell below your current location. This cell is a fully active Python session. So for example, Ashish, if you type 2 + 3, ShiftEnter. Now this is the important one, not enter, but ShiftEnter will execute your Python code. Okay. So at the minimum, this is an interactive way for us to write and run Python, right? And you can do everything we learned. You can define functions, blah, 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 print statements, anything you want can be done right there. I'm going to pause. Does that make sense? Easy? Okay. But immediately I'm going to say, look at the notebook that I've created. Apart from the code below, I'm also able to create all kinds of interesting text information for you to read. And later I'm going to show you how we can create images, right? And charting is a good way for us to analyze data. So really two reasons why I chose the notebook for today's discussion. One reason is, of course, it's a standard data science tool. But secondly, I wanted to show you some interesting charts and plots. And this is a nice way to show charts and plots. Okay, so let's just run that cell 2 now. Yeah, shift enter. It's good. No, yeah, you can hit the run button. If you like to, yeah, if you like menus, you can hit that. It'll take a second. It's going to bring in a few libraries. So now let me just mention the libraries that are important here is really this matplotlib library and the numpy library. Okay. I have a couple of other libraries. I was just testing if I can import them. I will talk to you about libraries later. Okay. So as you can see, I mentioned this below. You know, we have to use all these powerful and fairly complex libraries. The detailed analysis and discussion of what those libraries are, how we can use them, how can we manage data, how can we visualize data, blah, blah, blah. You'll get a flavor today, but I think we should spend time in an entire course just to do this, because there are so many interesting things and complicated and simple things that can be done there. So it will take a few sessions just to cover these topics. Okay, but you'll get a flavor today, and at the end you can tell me your interest to explore this further. Okay, so now we're ready to do our first exercise, right? We're going to generate some random numbers and we're going to study them. So let's go into the next cell. Okay, so what am I going to do? I'm going to generate a few random numbers, and then we're going to see what can we see, what are the patterns, etc. Okay, so the idea is that inside this library, inside Python and inside NumPy, there are random number generators. And if you want, I can give you references to the mathematics that produces the random numbers, right? I like this subject very much, very interesting. I will just share, I was in finance using random numbers at one point, and it's very interesting. If you do financial applications with random numbers, the solutions that you provide will depend on what kind of random numbers you use. And so one of my tasks as a quant was to find the right random number generator so that I could do simulations which actually have good results. So these subjects are very, very interesting. Okay. Anyway, so what do we do here? We import this NumPy library, and it has a random number generator. Now, one of the interesting things is just like I told you about pi, you have to pick a starting. Suppose I'm using the digits of pi. Then one choice could be, which digit shall I start from? Start from the first digit or the millionth digit or the 50th digit. That is called setting the seed for a random number generator, right? So if you set a seed, from that point on, the sequence that it generates will be the same. So for example, you see that random number dot random state, I set the seed, right? The seed is just a number. It could be anything. If you change the seed, then the sequence will change. Okay, if you don't change the seed, then you'll get the same sequence every time you run the program. And setting the seed helps me because I can, each time I run the program, sometimes I don't want different results, right? I want the same result so I can debug it, and you can see the same code as same outputs as I do, etc. So I fix the seed, but there's a whole exercise afterwards where you vary the seed and see what happens. Okay. So next thing is I've chosen the number of points to be 100, and I'll explain the scale parameter later. I set the scale parameter to be 1. Okay. And you can see I generated, so you can see I'm generating 100 points, and I'm multiplying each point by the scale. Okay, so we'll see the impact of scale in a second. So shift enter now, Ashish. So you get some numbers, okay? So now I'm going to pause and say, okay, we got some numbers. They are positive numbers, negative numbers. There's a bunch of numbers. What can you see any patterns here? Okay, so I love it that Ashish is driving everything. So I can just, I can do, it's like an AI for me. I can just talk to the, talk to the computer and some magic happens. Okay, so.
DJ, one question. Sorry to interrupt.
Yes,
I also ran the same thing. I did an alt enter, and I got error, name error. And it says it should be initialized with random number generator. With
No. Okay, start from the top. If you start from the top,
okay.
Yeah.
So basically LN2.
Wait. It's not alt enter. It's shift enter. Okay, and I'm going to give you a quick clue here. Every time you do shift enter, you see on the left there's a thing that says IN. That number will change. The first time you run it, it'll take a little while. You'll see a star there, and then when it finishes running, you'll get the number 1. So right now, for example, Ashish ran it, and it has the number 4. So you can actually see that the top cell was run after the next cell, because the next cell has the number 3. It's just a sequence count. Every time you run a cell, it increments the value. Okay. Now I just want to highlight to you as a programmers.
So for the same cell where you see IN4, I also see IN4, but for the next cell, that is RNG equal to that cell.
Yeah.
There I get an error when I do a shift enter.
No, but
It
what?
says
Me too. Me too. Same thing.
What's the error?
it says name error, trace back most recent call last, and initialize the it says NP is not defined.
Yeah, that means okay. Yeah, I think I understand this. Can you do you have what is the number? Can you run the first cell again? That cell which is matplotlib inline.
Okay, so that is like
Shift.
%matplotlib inline.
Yeah.
Shift enter.
Yeah, and does the number
Okay,
change?
I ran it again. Now it is IN5.
Okay, now come down and run the next cell. This cell.
Okay.
Ashish can run it too. It should increment to 5 now.
Yes. Okay. Yeah. Now it generated the
Yeah,
numbers.
yeah. So please remember, the idea is that there's a Python instance running in the background. Every time you run a cell, it goes and changes the state of this instance, right? Normally our programs execute from top to bottom. But here in the notebook, you can execute the bottom first and the top later if you want to. That will cause problems, right? In fact, it's one of the small problems here with the notebook is if you go to the bottom and execute the bottom cell, it's going to cause some problems because the top cell is not yet run. That's exactly the problem you saw. The top cell didn't get executed, so the bottom cell is saying, I have a problem. So usually you want to go from top to bottom, but now this is one of the pros and cons of interactive data science and Python notebooks. The whole idea of interactive data science is we want to push and poke at the data. I want to load data, change something, see what happens, change something, see what happens. But there is a dependency between things. And if you don't manage this dependency, you can create some mess. I updated the data, but the analysis didn't change. I updated the analysis, but I didn't update the data, right? So we can create some problems for ourselves. So this is a good moment for me to explain that. Okay, so we got this data now. So what pattern do we see here?
It's all
There is
negative.
Positive,
The random
negative.
numbers generated are same in all the places. Like in my screen and the one in Ashish's screen is same.
Yeah, that's because I set the seed. Okay, if anybody wants to try, you can change the seed. Don't change the seed now, but okay, you can change it and change it back. Okay, but if you change the seed, you'll get different numbers. Okay, but now I want to highlight why I went here is to do this analysis. If we can create an image, we will see patterns better than just staring at data. Right, and that's why I said we have to do a whole course on visualization. As soon as you can generate an image, you can see a lot of things. So let's go below, and I'm going to show you how to generate an image from this data. So you see this, it's one line really, but this line is complicated. But let's run it. Cool. What do we got? New York skyline, Cassandra? We got something, okay? So, but why do the random numbers look like this? What is this image? Why is this image connected to my random numbers? Somebody want to guess?
How many were? Because more of them are in the middle, and fewer of them at the edges, like
Exactly.
deviation, like
Exactly.
deviation.
Exactly. There's more in the middle, few in the edges. And how do I actually create? How do you actually create this shape though? If I said write a program to generate this image, what do we have to do? Take the data and do what?
Plot them, plot each one.
Yeah, if you plot each one, what is the x-axis? What is the y-axis? I'll show you in a minute what happens if you plot each one. Let me just give away the punchline, right? The punchline here is rather than plotting each of them, what I did is I took in the data is actually, if you look at this image, you can see there's lots of them around 0. And there's few of them as we go further and further out, both to the negative direction and positive direction. So we took the range between say -10 and +10, broke it up into buckets of uniform width. Okay. And you can, and inside each bucket, you see how many points fall inside each bucket. The vertical axis is the number of points that fall into each bucket. Okay. And then that's the plot. And this plot is called a histogram, right? You might have seen this in the past. What is important for those who work with Excel and other things? Look, try doing this in Excel, right? First of all, you have to get the random number generator. You have a lot of rows, and you have to bring up the chart menu. You have to set some parameters. You have to generate a histogram. Those who are good in Excel can do it very quickly. But at the end of the day, when you see the chart and you say, where did this chart get created, where's all the information, where's all the code? It's in various places. It's inside the chart control, it's here and there. But for me, all the code is there, right there in the one line that I have used. So it's easy for, I like this because I can go and manipulate all kinds of things, okay? But to control this whole plotting routine well, that's why I said it's a whole nother course. It's complicated and you have to know how to do what you're doing. But let's continue. Now, I have to ask a quick question. So if I increase the number of points, what happens? Does Ashish, you want to try to put, I don't know, 10,000 points? Do you think we'll break the system if we go up and say number of points, there should be a variable? Let's make everyone make it to, I don't know, let's go straight for 10,000. Okay. Another cool thing, right? At one point in Excel, if you go 10,000 rows and so on, you used to break it. They have removed the constraint now, but clearly this thing doesn't even blink right now.
It's a smaller set of numbers.
Huh?
It's a very small set of number now.
Is what, Kiran?
I said it's smaller set of numbers.
Smaller?
No, okay, sorry, no.
Yeah. It's just hiding somewhere, okay?
So if you see three dots, these are the ones where numbers have been hidden.
Yeah. Notebook is trying to be clever, right? Why spit out all these numbers? Nobody's going to read it, okay? These are all settings you can control. The notebook can control how many rows you see, blah, 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 okay? But anyway, let's look at the image now. What happened to the buildings and what do we see now? What does the shape look like? Can we find a name for the shape?
Much more like standard deviation.
Sorry, Cassandra?
Standard deviation.
No, yes. The plot has got a standard deviation. But what
Looks
is
like a hill.
Qualitatively? What's the shape look like?
Tower.
A tower. Okay. Anything else?
Peak of the mountain.
Yeah, it looks like a hill or a mountain, right? Yeah, it looks like a hill.
Yeah.
Okay. So, and some people see a bell when they see this. They call this the bell-shaped curve. Okay. Now, again, this is a long discussion why this shape is here, etc. But actually, I will say that it's interesting that random numbers have patterns, right? And mathematically, we can ask what is the equation that describes this pattern? Okay, and this work was done many years ago. Lots of mathematicians worked on it. One famous mathematician is Gauss. So the physicists actually honor the mathematician and they call this shape the Gaussian shape. The mathematicians notice that this shape shows up all over the place. So this shape actually, for example, if you take children of age 15 and you take, in a whole city and you plot the height of the children, right? You will get a bell-shaped curve. If you take children and you plot their weight, you get a bell-shaped curve. You take adults and you plot their salary, you will get a bell-shaped curve, right? And it's kind of interesting. Why does this happen? It's very deep mathematics, why it happens, etc. But heuristically, it makes sense, right? There's some mean for the population. That's where the peak starts to form. So for example, if I say, what are the salaries? Everybody makes some kind of average salary. Of course, there are billionaires on one extreme and there are very poor people on the other extreme, but there's less of them, hopefully, right? And if it's not, then there's something strange about the data we're looking at. So there's some universality of this particular shape, okay? Now this shape is in our data because this shape was actually used to create the random numbers. So there's nothing very complicated. These are called normally distributed random numbers, okay? And this particular choice of random numbers has a shape. So one of the things you do whenever you see randomness, maybe, is to plot and then recognize the shapes, right? And that becomes the science of statistics and probability when you start recognizing shapes and these functions that describe the shapes and so on. And my plan here is I want to create a separate course there, which is mathematics for data science, and talk about all these ideas, right? Interactively, of course, like we're doing. Okay, so let's go back. Let's set the number of points back to 100 and let's continue our exploration. Any questions at this point? You understand randomness and you get shapes and how you can visualize it. Yes?
I have so is this still, it's considered random or not?
It is considered random, but it was generated from an algorithm. Therefore, it's called pseudo-random. Okay. It's almost random, but not random. And what the idea is, whenever we write these things, they're called random number generators. We have created many random number tests. like Ashish was saying, okay, let's check if it's all heads or whatever. We check for patterns. If it passes all the checks, then we think it's a good random number generator. We cannot find any patterns, right? So some of these will pass more or less tests, depending. That's where the strength of the random number generator is. How many tests can it pass? Okay, but the idea is even if it passes all the tests we know, it's still pseudo-random. It fails on the one test is there a program that generates it? Yes, then it's not random. Okay, so yeah, we can discuss. It's a very interesting topic. Okay, so let's continue down.
I'll just make one comment because Cassandra asked. Can you show me the other plot where we had like a lot more the bell curve?
Yeah.
Okay. Ashish can run that, right? By increasing the number of points. Yes.
Yeah.
Isn't that a pattern? That's my question.
No. So yeah, I was going to tell you. So it's random because if you take this sample, right, and if I ask you what's the probability that the number, if you pick a number, how confident are you to say that this will be 0? You are not certain. Okay, the number can come anywhere between -4. It can also be possible that it can be -10, or it can be +10 or plus infinity, right? But the probability, if it's coming from this kind of distribution, right, this kind of setup, then only you can assign a probability that there's more likelihood that the number will be around 0. Okay, so random means that you cannot say with certainty. You can only assign a probability. Just like you throw a dice, you can only say there's a 1/6 probability that you will get a given number. So here also you can give some probability that a number, what's the probability that the number is between -1 and 0? I can say that there is some probability. What's the probability that the number is between -4 to -3? Lesser probability, much lesser probability. What's the probability that the number is between 0 to +1? Same probability as the number between 0 to -1. So here with random number, you can only give the likelihood. You cannot say with certainty that next time I draw a number from here, it can be between 0 and 1. You can only say it's between 30% chance. Okay, so that's why it's random.
So there will be patterns, and since Manish talked about dice, let's ask the questions. And you can do this as a homework assignment. You have enough tools to do this. You can generate random numbers, integers from 1 to 6. So you're simulating a die. And we'll do this. I'm actually planning it in the 4th session to do some simulations. So we'll simulate a die and we look for the patterns in the simulation of a die. But before doing anything, I can tell you, what do you think that curve is going to look like if I simulate a die? Well, if I do, let's make it divisible by 6. If I do 6 million simulations, if you do a histogram, you're going to get vertical bars, all of them of the same height. Each of them is going to have 6 million entries in it. If it's a good die, it's going to be equally likely. Right, so there will be a pattern there. That's a kind of uniform distribution, discrete uniform distribution. Okay, so yeah, so we can get different patterns and analyze them every time you see. So this is a very interesting thing. Whenever you see random numbers, if you plot them, it will show you some patterns. But like Manish was highlighting, and I was trying to say, is you cannot predict what the next number is going to be. You can just say that it's likely to be here 1/6 of the time, or it's likely to be more likely to be in the center. You can make some qualitative statements. Mathematically, we can make much more precise statements. I can tell you exactly what is a percentage in some interval, blah, blah, blah. Okay, that becomes really the study of probability. Yeah. Okay, so let's continue on our journey. So nice, interesting things to think about. You can try other sequences and you can plot them, etc. Okay.